So this is part of your investigation with your small group. We're going to look at 10 and 11. Those were the most challenging for most of you. So you discovered throughout the investigation that the Pythagorean identity is cosine squared of theta, or x, plus sine squared theta equals 1. Of course, you can have sine first and cosine second, like we talked about in class. And number 10, it gives you, and it asks you to use this Pythagorean identity. There are other ways to solve this, but we're using this method so we can understand about the Pythagorean identity. So it tells you that angle theta is located in quadrant 1. So we know that all of our functions in quadrant 1 are positive. So we know if we're looking for cosine, it's going to be a positive value. So that's something we already know. So if we think about first what we're given sine of theta. And remember, sine of theta is the same thing as opposite over hypotenuse. So that means we know that the hypotenuse is 20. And we know that the opposite is 17. So if you thought about this in a visual format, and we were in quadrant 1, and we drew a right triangle, right? So we would have a hypotenuse of 20. Our theta would be here. And then opposite of that would be our 17. We don't know what this value is, okay? And we need to know that for our cosine, because cosine of theta is the adjacent over hypotenuse. So we know already that this is going to be 20, but we don't know what A is going to be. Now, an easy way we could use Pythagorean theorem, but we're using Pythagorean identity. So we're going to plug in what we're given. So we were told that sine of theta is 17/20. So we're going to plug it into our formula. So this is sine squared. So we just know sine, so we're putting in 17/20, and then we're going to square it. Now, when we go to put this in our calculator, it's best to keep it as fractions. So 17/20 squared is actually 289 over 400. So this is cosine squared theta plus 289 over 400 equals 1. Then we're going to move everything away from the cosine squared. So we would subtract from both sides this value. Okay, so 289, 400 from 1, and that gives us cosine squared theta equals 111 over 400. Well, to undo a square, we have to take the square root. So if we just want to know what cosine is up here in our problem, we take the square root of this side, and we have cosine. We take the square root here and the square root here, because these are individual pieces, they're ratios. Don't do the whole thing. That's not going to help you very much. So, square root of 111 gives us a long decimal, 10 point something, something, something. So we're going to keep it as just the square root of 111. Square root of 400 is 20, which it should be 20 because that's what our hypotenuse should be. And so that tells us that this is square root of 111. Now, if we wanted to check ourselves with Pythagorean theorem, if we knew here that 17 squared plus some unknown, we'll call this x, equals 20 squared, we could then solve and see if we got the square root of 111. So 17 squared is 289. Take that away from 20 squared, which is 400. So 400 minus 289 gives us 111. So x squared would be 111, and then square root, and we would have square root of 111 for that value. So we determined the cosine was 111, and it's in quadrant 1, so it has to stay positive, and then that is our value. Now, let's look at number 11. 11's a little bit trickier because we have to think about the restrictions we're given. So if we look here on our unit circle, and it says we are between pi divided by 2, theta is greater than that, and it is less than pi. So think about where that would be on your quadrant of your unit circle. So we would actually be in this value right here. And if you think about all students take calculus, this is where the S is, okay? So the only thing that's going to be positive in that quadrant is our sine and its reciprocal. So our sine is given to us as 1/2. We know it is going to be positive. It's given to us that way, and we know it's the right quadrant. It wants us to find cosine and tangent. Well, they're going to be in that quadrant. So if we're thinking about what we're looking here, we're drawing a right triangle that, is over here in this quadrant. The only thing over here is going to be sine that's positive. Now, we already know our hypotenuse is 2. And we already know if we're talking about theta being here, because that's our standard position, then we know opposite of that is 1. Now we can find our other value, our x value, by using Pythagorean theorem, but we're using Pythagorean identity. So we're going to plug in what we have. So same as before, we're going to do cosine squared theta plus 1/2, that's our sine, squared equals 1. All right, and then we're going to go ahead and solve. So 1/2 squared is 1/4. We're going to subtract 1/4 from 1. So we're going to end up with cosine squared theta equals 3/4. And then we're going to take the square root. So square root of all pieces. And what we're going to end up with cosine of theta equals square root of 3 over 2. Now, we have to remember our cosine has to be negative because we're in quadrant 2. So this has to be a negative square root of 3 over 2. So now we're going to find tangent. So remember, tangent is the same thing if you use your identities of your quotient identities. Tangent is the same as sine over cosine. Okay, so tangent, we use our sine of 1/2 divided by our cosine, square root of 3 over 2, make sure it's a negative, and then you can do the reciprocal. So we would have 1/2 times 2, make sure there's a negative out there, square root of 3, multiply straight across, we would end up with a negative 2 over 2 square roots of 3. We cannot leave that square root symbol in the denominator. We've got to rationalize that. So we multiply both by square root of 3. And what we end up with is negative 2 square roots of 3 over 2 times 3, which is 6. So we get 2 square roots of 3, again negative, over 6, and then we need to simplify. So this is square root of 3 over 3, and the negatives out front. So this is your tangent. All right. Now, also, we want to find out, it asks us how to determine the measurement of angle theta. Okay. So if we want to determine the measurement of it, we can think about what can we do to help us find it. Well, if we use tangent, we just found tangent, and remember, if we're going to think about tangent of theta, and we know that tangent is square root of 3 over negative 3, we can put this in our calculator using the inverse. So we'd say tangent of negative 1 of square root of 3 over 3 with that negative, and what we get out is a negative 30. Well, we know that we can't have a negative 30 in that section because we're in quadrant 2, so that's a restriction. So we could think about it, we could either divide sine by cosine and use the inverse, or we can think about how do I change it to be a positive in that area, because we know that that's still a positive degree. So we would, because we know we're in quadrant 2. So we could add 180 to it, and we get 150 degrees is where we would be.